Hello General Math students. So we're going to look at growth and decay, in particular graphing sequences in this video. You can see some arithmetic sequences here. They form straight lines when they're graphed. Okay, and here we've got some geometric sequences. Almost all of these form some sort of curve shape, so they're non-linear in their shape. We have a straight line down for that one there, when that one's in equilibrium. And there's a couple here that are a little bit different. These are these sequences where the R value or the ratio is negative. We have these alternating sequences. Here this one is decaying, and this one here is growing, but they oscillate and form sort of this this shape. It's unusual because the data points oscillate between the positive and the negative. Okay, now we've got some sequences that we're going to graph here. We're also asked to predict the shape of the graph. Now if we look back at the arithmetic sequences, we can see that if the common difference is greater than 0, then we're going to get a positive growth, or a growth in the positive direction. So for the with a straight line, of course. So if we're looking here, our common difference is 5 this time, so it is greater than 0, right? So that means we're going to have a growth. The general shape of this graph is going to be that it goes upwards like this, right? If D was negative, less than 0, then we have a common difference that's negative, and obviously we go downwards. But this one has D greater than 0, so we're going to get this upwards shape. Okay, so we'll do a quick working out of the data points here. We're just putting n equals 1 into this. 1 take 1 is 0 by 5, so the first term is 10. And then you might want to pause the video and work out the rest of these, and then I'll have a go at them very quickly. Okay, so we're getting 15. We're going to go up in 5s here. 25, 30, and 35. So term down here, the n value, the term 1, 2, 3, 4, 5, 6, and up here we've got oops, we'll just leave that as an n value down there for the position. Here we've got Tn. That's where I should put that one. Okay, so we need to go up to 35, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That'll do. Okay, so this graph will look like this one, going up in 5s from there. 15, so something like this. We want those to be in a straight line, okay? All right, next one. Now, here we want to look at the R value. What does and the A value as well. They're both important. So in this geometric sequence here, we have an A value that's greater than 0. All right, and we have an R value between 0 and 1. So A greater than 0, R is between 0 and positive 1. So you might want to go now and look for that graph on the previous slide on your book and see if you can pick the general shape of this graph. Then I'll have a go at it. Right, so A greater than 0. Okay, so we've got these two here. So it's either one of these where A is greater than 0. This one has R greater than 0 as well, but we want the one where R is between 0 and 1. So this is the general shape of our graph. That's the one that we're going to get that sort of decaying geometric sequence. So it's going to come down like that. That's going to be the general shape. Righto, so we'll figure out what the values are. Obviously we start with 80 is the first term because that number's out the front there. So 80, and it's going to go down by half each time. So you should be getting pretty good at these. Realise that that ratio means it'll halve each time, so I won't need the calculator for this after all. Okay, so here we've got Tn on this axis and just n number of terms here. This scale will work again. We need to go up to at least 80 this time. 10, 20, 30, I reckon we'll go up in tens. 50, 60, 70, and 80 there. And that's where we start. I'll use a cross this time. Second term, oops, beg your pardon. Now that would be with term 0. So I'm meant to go term 1 here. So I got that one out of line, meant to go there, not on term 0, because this is the first term. First term's here. So that was my mistake there. I'll fix that up. Okay, then term 3 is at 20. Term 4 is at 10. Then 5 and 2.5. So there is that shape we were talking about. Okay, last one. So in this one, we're looking for a greater than 0 again. And we're looking for the r value to be negative, so r less than 1. Okay, go back to that other page and find a greater than 0, r less than 1. What will the shape be? Okay. So, in fact, not quite right on that one. Sorry, I should have said r less than negative 1. Beg your pardon, because it's greater than negative 1. My mistake. So you may have realized by now that the one we're looking for is here. And notice they don't actually speak or show anything about the a value there. It doesn't really matter what the a value is. If r is more negative than negative 1, we're definitely getting this shape to our graph, this diverging sequence. So with this one, we're expecting the sequence to oscillate or alternate between positive, negative, and diverge in its shape. Righto. So the first term is 5, and then we're going to multiply by negative 1.8 each time. Okay, so we get negative 9 for the next term, and then that times negative 1.8, 16.2, and we'll keep going until we get all the way there. Oops. Negative 19.44. Just make that a bit smaller. 16.2, negative 19.44. This is very hard to squeeze into this table. Times negative 1.8 goes back to 34.99 to pretty much 35 there. And then the last one, negative 62.99. Pretty much 63. That's what it'll certainly look like on the graph anyway. Okay, so we've got to go up to about, say, above 62.99, so maybe 70. Probably this scale here is appropriate. It's nearly up at that sort of number, so we'll do that. 40 and 80. This is our Tn. Here is our n number of terms, 3, 6, there and there. Okay, so term number 1 is at 5. Oh, hold on, beg your pardon. We're going positive to negative, aren't we? Oops, I better fix that. That's no good at all, because we need to go into the negative region. All right, so instead of going from 0 up, I need to start my axis here for 0. And need to have some positive values up this way and negative values for my terms. That this axis is fine down here for the n number of terms, 3 to 6. Okay, so let's say 10, 20, 30, 40, 50. So we'll go up in 20s, I think. So 20, 40, 80, there and there. And then we can go negative 40, negative 80. That way. That should cover us. Okay, so the first term is 5, so that's like about here. A little bit higher than that maybe. I'll go with a dot on this one, about there. And then negative 9 takes us down to about there. 16.2, about here. Negative 19, pretty close to 20. Negative 20, so we'll go there. Just lift him a little bit, make him a bit closer to the negative 20. Then 35 is about here. And finally 62, negative 63, about down there. Okay, so we can see that diverging sequence. And it might pay to put an x-axis in there just to show there is the n there. I might put my labels up there as well. Okay, so we can get an idea of what the shape of the graph will be from the A value, the first term of the sequence, and the R value, okay? But once we plot the graph, it becomes clear what the shape is as well, and that's how we do it. Okay, guys, go and check the description for the video and get plotting.